Today we're going to talk about the IRA procedure. Of course, like all of the Acme test procedures, you can find it on the intranet under ASTM test procedures. The main reason that we do the IRA test is it's kind of a test that helps the brick masons out. Kind of indicates what kind of bond you're going to get with the mortar out in the field. If you get a brick that has too high of an IRA, it tends to suck the water out of the mortar too quickly, and you may not get, your bond may be weak. On the other hand, if you have a brick where the IRA is extremely low, then it takes a long time for it to bond, and then it slows the bricklaying process down. And if you're going to do a set of these at the plant, you want to make sure that while we're only going to demonstrate one today, that you would want to do a set of 5, because that's normally what we do as part of our normal ASTM testing. When we get a set of brick in to do the IRA, the first thing we're going to do is dry them out for at least 24 hours at a minimum temperature of 250 degrees. So we've got our brick in the oven here. Once they're dry, we take them out, and of course we have to let them cool down to room temperature before we can start doing the IRA test itself. So once the brick are cooled down, first thing we do is weigh the brick dry, get a weight on that. Then we look at the pan of water over here, which is where we're going to put the brick in here in a minute. If you look at it, this is kind of our guide brick, and you see it says IRA on here. This is a very low absorption brick, and you can see the black line there, which is the level that the water is going to start out the test at. Of course, we're just going to test one, but when you're doing a test at another location, or you ever want to do it at a plant, you will do it with 5 brick because you want to do a full set of brick. So what he's going to do is, once you've put the water in here, and this water can just be tap water, it doesn't have to be distilled water, you'll basically time it for a minute, and then you're going to take it out of the water, as you'll see, and then you're going to dab the excess water off, and you're going to weigh it again. Go ahead, Tim. So you'll need a stopwatch for this. He's got one over here. We just have one that constantly runs, but at your location you can just take a stopwatch and run it as you see.
Might as well kick it on.
Okay.
So now he'll take the brick out of the water after a minute, dab the excess water off there. It's just a regular rag, cloth type thing that you can use. Once you've done that, put the brick back on the scale, and that'll give you the wet weight.
Okay.
Okay, now we're going to go through the calculation now that he's finished the testing. Before you do the calculation on your IRA, you will have had to have done your measurements, length, width, and depth, as well as your void, because that's part of the calculation, as you'll see here shortly. So the formula for the IRA is this formula on the board here. The 30 is a constant, and it's always there. You don't need to worry about that. The W is going to be the amount of weight that was gained in the water. Your L is going to be the length of the brick. The D is going to be the bed depth of the brick. And then you're going to take out the void by saying you're going to subtract from 1, and you're going to take out the void percentage. So in this case, we started out with a brick that was 1,536.3 grams, and we ended up with a wet weight after it came out of the water of 1,554.0. So the first thing you'll do to get your top factor here, take 1,554, subtract 1,536.3, and that gives you 17.7. So the top will be 30 times 17.7. On the bottom, we measured this brick, has a length of 9.63, and this formula is set up to be done in inches. There is a metric version of this, but most all of us always measure brick in inches, so we'll stick with this formula here. So 9.63 is your length. Your bed depth on this, 2.65. And your void percentage is 28.1, so right here it'll be 1 minus 0.281. So to get your top, obviously, 30 times 17.7 gives you 531. And down here, this 1 minus 0.281 to take care of the void, that's going to end up being 1 minus 0.281 is 0.719. So your bottom here is going to be your length, 9.63 times your depth, 2.65, multiplied by your void removal, 0.719. That gives you 18.35. And then to get your final IRA, you just take your 531, divide that by 18.35, and that gives you an IRA on this brick of 28.94. So that gives us 28.94 for the IRA on this particular brick. Given this formula, the units for IRA are actually in grams per minute per 30 square inches. Now, normally on an IRA, like we say, if it's 30 or above, that's considered abnormally high. Something below 5 would be considered extremely low. So as you see in this case, this is a brick that's kind of on the high side, and there may be some concern out there in the field with mortar bond being weak because of this high IRA.